All right, for number two here, and I'll talk about a little bit of number one here for just a second again. So we have c, which is the speed of light, 3.00 times 10 to the eighth meters per second. Lambda is wavelength for a particular light, and nu, which is, this is a Greek letter N, but it looks like a cursive V, is frequency. And so in this case, let's see what we need to do. So 3.00 times 10 to the eighth meters per second, always going to have that. Lambda, what is the wavelength? So that means lambda is going to be my unknown here. And this time nu is given. 5.83 times 10 to the 14th per second. So I'm going to use the same equation, but solve now for nu instead of lambda. So c equals lambda times nu. Therefore, lambda is equal to c divided by nu. 3.00 times 10 to the eighth meters per second. And now on the bottom, 5.83 times 10 to the 14th per second. And this second and this per second here, those cancel out, which is good. And what we get out of here is a length unit, which is what we need to. It's a wavelength, so we need to get a proper unit of length. We get a meter out of this. Okay, and what I end up getting for this is 5.15 times 10 to the minus 7 meters. You can go through and do the calculation for nanometers properly if you want to, but you'll notice if you do a few of these that what ends up happening is I can rewrite this as 515 times 10 to the minus 9 meters. Okay, I've made this first part bigger. I went from 5.15 to 515, and I've made the second part of the scientific notation smaller by the same amount. So 100 times bigger and 100 times smaller. And so now what's nice about this is I can just write this as 515 nanometers.